Welcome to day 3 of areas of regular polygons. We're going to do pentagons and octagons today. All right, so recall from yesterday we talked about the area of a regular pentagon is 1/2 AP, where little a is the apothem, and of course P is perimeter. So, given the apothem and the perimeter, it is quite easy. We just say A equals 1/2 AP. So 1/2 our apothem of 11, and our perimeter is 16 times 5. So this gives us 440 feet squared for the area of this guy. Easy enough. All right, now what if we're given the apothem and the radius? Well, here I do not know this segment right here. So I can use the Pythagorean theorem to solve for this half of the side length because it belongs to the triangle. I can say 8 squared minus 6.5 squared equals x squared. So that gives me x squared equals 21.75. So x equals the square root of 21.75. And that is, if we go to our handy dandy calculator app, the square root of 21.75 is 4.66. So here we go. This is equal to 4.66. Now, the perimeter, if I've solved for x, I've gotten half of one side. So there's x here. So this is 2x, this is 2x, this one is 2x, and this one is 2x. So altogether there are 10 of these in a pentagon. So 10 times 4.66 gives me 46.6. So now my area is 1/2 times the apothem of 6.5 times my perimeter of 46.6. So that is going to be equal to 1/2 times 6.5 times this number. Hang on. 1/2 times 6.5 times this number times 10. And that is 151.57. So that's our answer. 151.57. There it is. All right, easy enough. Now, it does get a little more difficult. What if we are only given the radius? So we're given the radius here. Just like in our hexagon and our equilateral triangles, we are going to draw in this triangle. Now, let's think. If I were to go all the way around this pentagon, all the way around, this is 360 degrees. So this little bit right here, I could divide this up into 10 triangles. 10 of these triangles. So this angle is 360 divided by 10, which is 36 degrees. So that's the angle. So if I pull this triangle out, it looks something like that. No, that's not a good version of it. There's our triangle. This angle right here is 36 degrees. I'm given this side length of 4, and I'm given this as A, and this we will call X. So this is my X, this is my A. Now, remember, when we have a side length of a right triangle and one angle, we can use ka, toa, trig functions. So I know that A is adjacent to 36, so cosine of 36 is equal to A over 4. Sine of 36 is equal to X over 4, because that's the opposite to the 36. So using each of these, 4 cosine 36 is equal to A, and that is 4 cosine 36. Make sure your calculator is in degrees. 3.24. So A is 3.24. My X is 4 sine 36 equals X. And that is 4 sine 36, 2.35. 2.35. Now remember again, for my perimeter, I've got 10 of those. So 10 times 2.35 gives me a perimeter of 23.5. So my area now is 1/2 AP. So this is 1/2 times the apothem, 3.24, times the perimeter of 23.5. So this gives me an area of 1/2 times this number times 10 of that number. So 38.04 is my area for this guy. 38.04. No units given. So that is it. There we go. So that's with the pentagon. Remember, I can divide this up into 10 pi segments to make there's 10 of those such triangles that I can do. So I do 360 divided by 10 to give me the angle of 36 degrees. And then I know using trig functions, so SOHCAHTOA, cosine is adjacent over hypotenuse, and my sine is opposite over hypotenuse. So that's how I know to set these two functions up. We can do it like that with any one of them, whatever shape it is, but we're going to focus on pentagons and octagons today. All right, so again, given the apothem and a side length, very easy. 1/2 AP. So this is 1/2 times my apothem of 12.1 times my perimeter of 10 times 8 of those. So multiplying all this out, we get 484 inches squared. All right. Now, what if we are only given the side length? Okay, so as always, we're going to find our center. We're going to draw in this triangle right here. Okay, we know this is 4, so this part is 2. Again, consider all the way around our shape here. I know that because there's 8 sides, that means I can make 16 of these triangles. So I'm going to divide 360 divided by 16, and that gives me 22.5 degrees. That is this angle right here, is 22.5 degrees. All right? So that means my triangle, if I pull it out, looks like low power mode. This is a right triangle, and this is 22.5 degrees. I know this side is 2. I need to know my apothem. There's my apothem. So when I'm given the side length, remember, we're going to use SOHCAHTOA. And I know that this tells me that tangent of 22.5 is equal to opposite over adjacent, 2 over A. Now, in looking at this, I recognize this is a 22.5 degree angle, so therefore 2 is the smallest side. So when I multiply all this out, I should get an apothem that is greater than 2. If I don't, I've set it up incorrectly. Always make that check. Is the side length I'm looking for bigger or smaller? So when I've got my variable in the denominator, I know I can just do a switcheroo. A equals 2 divided by tangent 22.5. So my apothem is alpha y equals enter 2 over tangent 22.5. Boom. 4.28. If I had set it up the wrong way, if I did 2 tangent 22.5, that's the other possibility. You see I would get 0.8. So I know that 4.83 is the actual apothem here. This is 4.83. All right. Well, now we've got what we need. Area equals 1/2 little a times p. So 1/2 times my apothem of 4.83 times my perimeter. I've got 2 times 16 or 4 times 8, which is 32. So let's multiply all that out. I need 1/2 times this number times 32, which gives me 77.25. 77.25 inches squared. Didn't think that was a rectangle. All right, one more problem today. So here we go. This time we are given the radius. So again, we will build this triangle here. I need to know apothem and x. So this one's going to work just like we did on the previous page. Okay, I've got a 22.5 degree angle here. This is my A, this is my x, and this is 2. So again, setting it up the same way. Cosine of 22.5 equals A over 2. Sine of 22.5 equals x over 2. So 2 cosine 22.5 equals A, and that is 2 cosine 22.5, 1.85. And 2 sine 22.5 equals x, and that number is 2 sine 22.5, 0.77. All right, again, let's calculate the perimeter. Note that the x that I solve is half of a side length, so I need 16 of those to get my perimeter. So multiplying that number times 16 gives me 12.25 as the perimeter. Okay, so again, A equals 1/2 little a p. So my area is equal to 1/2 times apothem 1.85 times perimeter 12.25. So that's going to give me 1/2 times that number times my perimeter, which was this number. 11.31 is the area of this guy. And no units. So there we go. All right, any questions? Find me before school tomorrow. Sorry I missed you guys today. And take care. Until next time.